you guys for both blue and red kids. Today, we're taking notes on 3-2, so that's what you guys will do tonight. Now, for red kids, you guys, if you have questions on 3-2 as you do it tonight, shoot me an email with your questions, and I'll make sure to do it in class tomorrow so you can watch those. And then same thing with the next night. Like on Thursday, I want you guys to get on Schoology and watch the notes from the day on 3-3. I will probably post them around 10:30, but at the latest, I'll post them at noon. So watch those notes and then do that worksheet. And same thing, email me with questions so I can go over those on Friday. And then Friday, there will be a video for 3-4 in that worksheet. And then over the weekend, you're gonna do 3-5, which is a review. So you are ready for your online quiz through AP Classroom on Monday. So for those of you, I have had several of you guys add the class recently. If you're a new ad, make sure you've signed up for our AP Classroom by Monday and try to do it early in case there's issues. The directions are at the top of Schoology. So that's your game plan for the week, whether you're red or blue, that's what we're doing for the week. And that gets us through Monday. And then next week is when we'll go over the Chapter 2 test. And we will do that, I think I see you guys on Wednesday, is that true? So we'll go over that on Wednesday. Which if all we're doing is taking a test on Wednesday, that leaves about 15 minutes for something else. Leaves about 15 extra minutes there. Okay, questions on what we're doing this week? Do you guys know what you're responsible for? Okay, tonight, please, once we've gone over 3.1, submit your 3.1 tonight. If your 3.2 is ready to go, you don't have questions, you can submit that as well, but otherwise email me questions and wait till you get those resolved before you submit. Answer. Totally. I follow all the rules. That's on record too, I reported that. Okay, you guys, we are starting notes in 3-2, which is all about relative mins and maxes, but we're gonna start just by looking at this graph so you guys can understand what we're doing. And we will go over 3-1, but we'll save it till the end. Time was not an issue at all last period. I just wanna make sure we do a thorough job of 3-2 notes, and then we'll know what time we have left for questions at the end, okay? And if we don't get to all your 3-2 questions, I can make a video recording for you guys to watch later. So that won't be an issue, but let's do notes first. So yesterday, we were finding absolute mins and maxes. So the very highest point on the graph and the very lowest point on the graph. So in this graph, we have an absolute max right here. And then an absolute min over here. And just a little vocab, remember absolute we also call global. So that's our global min and our global max, the overall minimum and maximum value. Today, we want to find local mins and local maxes. So in this graph, if we're looking at our local maxes, let's say, there's a local max right here, and a local max right there. And then we also have some local mins. Here's a local min, and there's a local min as well. Now, what I want you guys to get is what local maxes have in common and what local mins have in common. So local maxes and mins depend on where the function is increasing and decreasing. So remember, we read a graph just like we read a book. We're reading it left to right. So as we're reading this graph left to right, the graph is increasing when it's going uphill, and it's decreasing when it's going downhill. So this graph is increasing here, and here, and here. And then it's decreasing the other places where it's going downhill. So there, and there. So let's start with the parts in green, which is our increasing parts. If the graph is increasing, what do we know about its slope? It's a positive slope, right? All increasing functions have a positive slope. They're going uphill. One of the biggest central ideas of this whole class is that the derivative is the slope. So if a function's increasing, that means its slope is positive, which is like saying the derivative is positive. So all of the places I highlighted in green, we would say the derivative is positive, or in other words, greater than 0. So then similarly, if a function's decreasing, its slope is negative, which is like saying f prime is negative or less than 0. So let's look at our local maxes. They're here and there. In terms of increasing and decreasing, what did our local maxes have in common? What's the same about both of those maxes? What changes? Yes, the sign of the slope went from positive to negative, which is like saying the derivative went from positive to negative. So for a max, f prime goes from positive to negative. And then similar idea for a min, f prime goes from negative to positive. For a min, we're going red to green. For a max, we're going green to red. So today, our goal is to find our relative mins and maxes. So we're not talking about the absolute highest and absolute lowest value. We're talking about our relative ones. And that depends on the sign of the derivative. So for relative mins and maxes, we need to make a sign chart. So remember yesterday I said I want you guys to really focus on the difference between absolute maxes and mins and relative maxes and mins. Yesterday for absolute, we made a table of y values and just took the biggest y value and the smallest y value. Today we're making a sign chart with f prime. We want to know the sign of the slope to know if the function's increasing or decreasing, and that tells us if the function has a max or a min. Okay? So we're going to go through 4 examples, and then we'll go over homework after that. So for number 1, it has several directions. It says find the critical numbers, find where the function increases and decreases, and then locate the x value of the local extrema. So part A is a review from yesterday, finding the critical values. So we have our function f of x is x cubed minus 3/2 x squared. Help me out, you guys, remind me, what are critical numbers? Perfect. It's where the derivative is 0 or where the derivative is undefined. A lot of times we remember it's where the derivative is 0, but don't forget it's also where the derivative is undefined. So think to check those places as well. So when we're finding our critical numbers in part A, we're taking the derivative and setting it equal to 0. And remember, we're showing that really clearly. Your derivative should be labeled and you should show that you're setting it equal to 0. So this one, if we're setting it equal to 0, we can factor out a 3x. And so we either get x equals 0 or x equals 1. So that's where the derivative equals 0. Rachel said it's where the critical numbers are where the derivative equals 0 or doesn't exist. Think back to this derivative. Is there any x value I would plug into 3x squared minus 3x and get something undefined? No. So the derivative exists everywhere. So our only critical numbers are coming from where the derivative equals 0. Okay, so that was part A, finding the critical numbers. Part B says determine where the function is increasing or decreasing. Well, think about the graph we drew. Increasing and decreasing depended on the sign of the derivative. So for part B, we need to make a sign chart. We're putting all of our critical numbers on that sign chart and then going from there. So on our sign chart, we're going to have 0 and 1. And tomorrow we're going to be working with F double prime. So just to keep your sign chart organized, label what sign chart you're making. So on top, we're finding the sign of F prime. And then on bottom, we're going to write what it tells us about the function F. Now for our sign chart, we want a sign for F prime. So we need to do a test number for this far right region. So this is a review of building sign charts. When you're building sign charts, I want you to do one test number and then use what you know about bounce, wiggle, cross. So for the interval 1 to infinity, we need to pick one number that's bigger than 1 and plug it into the derivative. Remember, we're plugging it into the derivative because we want the sign of the derivative. We don't need the sign of the original function. We need the sign of the derivative because we want to know if the slope of the function is positive or negative. You could use the 3x squared minus 3x or factored form, but factored form will be easier. So you can plug any number in bigger than 1. So a lot of you guys use 2, which is fine. You could use 2, 3, 4, 10, 20, 40. It doesn't matter. I almost think it's easier if you use a really big positive because then it's more obvious what's happening. So say we plug 100 into the derivative. Won't that say 300 times 99? I don't really care what value that is. The important part is that it's a positive number. So we're going to label F prime as positive there. From there, I don't want you to do more test points. I want you to use what you know about bounce, wiggle, cross. So what I mean by that is at x equals 1, didn't that come from the factor x minus 1, which was to the first power? So isn't that a cross in the graph? Meaning if to the right of 1, we're above the x-axis, it should cross through the x-axis. So to the left of 1, it crossed through. So that would make it change signs. So this should go to negative. And then at 0, this x equals 0 came from this factor, which also is an odd exponent, so it's another cross in the graph. So just as a reminder of building sign charts, if the exponent is odd, that was a cross or a wiggle in the graph, so the sign should change. If the exponent's even, that was a bounce in the graph, so the sign should stay the same. So I don't want you to do a test value for all 3 regions. Just do the far right one and then do bounce, wiggle, cross. If it's a polynomial. If it's a trig function, trig functions don't use bounce, wiggle, cross, so then we'll have to use other methods. But for polynomials, use bounce, wiggle, cross. So now what I know is f prime is positive in this first interval, and remember f prime's the slope. So if the slope of f is positive, what can you tell me about f? What is it doing? It's increasing, right? It's going uphill. So you could label that in your sign chart a few ways. Some of you draw a little arrow going uphill, or you can write increasing. So then it would also be increasing on the interval 1 to infinity. And then it's decreasing where f prime is negative. Before we interpret the sign chart, what are you guys wondering about building it? Just keep in mind, because I know this unit gets confusing because we're working with 3 different functions. We're working with f and f prime, and then tomorrow we're going to be working with f double prime. So you guys start to get confused what you're plugging in where. Remember, when you're building a sign chart for f prime, you want to know the sign of f prime. So when we did our test number, we plugged 100 into f prime, not the original equation. Because I want the sign of the slope, not the sign of the y value. Okay, so from there, the second question was, where's the function increasing or decreasing? And we need to justify. Your sign chart is a tool to help you answer the question, but your sign chart's not justification. So when we're answering the question, we would say f is increasing on the intervals -infinity to 0 or 1 to infinity. We'll get to the brackets and parentheses and that weird U I put in a minute, but for our justification, what would our reasoning be? How did we know based off the sign chart that f is increasing there? F prime was positive, perfect. So because f prime was positive, you can write out the words f prime was positive, or if you want to save yourself a little bit of writing, if f prime's positive, doesn't that mean it's greater than 0? So math speak would be f prime of x is greater than 0, or you can write out the words, whatever you prefer.